All right, so today our lesson is going to be on molecular formula. So last day I was hinting at we would move to this, piggybacking on top of the empirical formula lesson. So hopefully you have the empirical formula information down and are confident with it. If not, go back and do that and then come back and then come to this lesson next, okay? All right, so empirical formula again is the simplest kind of the reduced formula way of writing elements, but it wasn't necessarily the chemical formula that represented the element, okay? We were just looking at taking some data from the, like running it through maybe a mass spectrometer, finding information about there's, this percent of this element and this percent of that element making up that compound, okay? So we can kind of get a general formula, ratio formula built and present that as an empirical formula. But today we're actually going to move into the actual chemical formula that we have been using to balance in our reaction equations and so forth. So the molecular formula will give you the exact number of elements that are in the compound, okay? And we can, do this obviously with finding, running some more tests and so forth and using the empirical formula. So the one extra step on top of all the empirical formula steps that we did last day is that we are also given the molar mass. Okay, so that was one clue that we didn't have last day. So that is the thing that we need in order to get to the molecular formula. Okay, so what's going to happen here is you're going to get a question. You're going to get, mass data, percent composition of this and that, and you have to go through and find the empirical formula. But then there's, right at the end, you're going to take the molar mass that's also given for the actual compound and the molar mass of the empirical formula. You're going to compare them and see how many times greater the molar mass actually is. And you're going to multiply all the subscripts by that multiple. Okay, so anyway, that's kind of the reference point that you can come back to and look at again, but let's actually do an example to solidify this, okay? All right, so example one here, I want you to find the molecular formula for the following here. They actually already give you the empirical formula, so we could, skip that step and go right into finding the molecular formula, okay? So for now, so just pretend that you went through all the things that you did with the empirical formula and then you got to here, okay? So you have your empirical formula and it's CH2, like that, okay? All right, so our goal today is so that's given to you, okay? So today your goal is to find the molecular formula. And we'll call that MF, okay? Just for short. All right, so we need the molecular formula for the CH2, so I'm just gonna, call it, that for now. We don't know the actual, so we have to find that. Okay, so what's our plan here? So what we're gonna do is we're gonna take our empirical formula and we're gonna multiply it by our multiple here to get to our molecular formula. Okay, so how do we get to our multiple? So all we're going to do is we're going to find the molar mass of the empirical formula. So let's do that up here. So the molar mass, so that's the molar mass, just in case you forgot that capital M, molar mass. Okay, so we're finding the molar mass of CH2. So let's go through and do that. So we have one carbon and we have two hydrogens. Okay, so a carbon brings forth 12.01 and hydrogen, there's two of them, so multiply that 1.01 and then crunch that out. So you get 2.02 plus 12.01 and then don't round up. Okay, carry all your digits. This is not your final answer. Okay, so there's your molar mass. So you have your molar mass of your empirical formula, and so now we have to find the multiple here. So to find the multiple, all you're doing is you're taking your molar mass of your molecular formula, okay, and you're going to divide it by the molar mass of your empirical formula. All right, so that's kind of what was written up here, okay? Molar mass of the compound divided by the molar mass of the empirical formula. So in this case here, so let's actually crunch this out. We are given the molar mass. So I guess I should have written that up here. I was given the, I could find the molar mass of the empirical and then the molar mass of the, the one that we need to find. So maybe I'll call it C, like that. The one that we need to find, I was given that it was 84.18 grams per mole. Okay, so I was given all this information. So all I'm going to do is take that molar mass and divide by the molar mass of the empirical formula. And I'm going to figure out how many times greater that molar mass is by dividing them out, and you get 6. Okay, so you have your empirical formula is 14, and the actual compound is 6 times. Okay, that empirical formula. So what you're going to do here now is you're going to go to your empirical formula. So again, there's your empirical formula, and you're going to, so again, you know that like this is 1 carbon, right? So you're going to just take that and multiply by your multiple that you just found. So you're going to times that by 6, times that by 6, and your new molecular formula is now C6H12. Okay, so that's what you're doing today. You're doing what you did last day with empirical formula, getting to your empirical formula, and then from there, you're going to use this one new piece of information, the molecular formula of the actual compound. You're going to take it and divide by the molar mass of your empirical formula, get your multiple here, and you just multiply the subscripts by that multiple. Okay, so here it was C1H2, right? And you just multiplied it by 6 to get C6H12. This is the actual chemical formula for the substance that they ran through the machine and so forth and found this information with, okay? All right, so don't forget your therefore statement. Remember to use your keywords. What is it that you had to find? You needed to find the molecular formula. Okay, so the molecular formula is, and then write your answer, C6H12, like that. Okay, some of you are writing your subscripts really big, so make sure to write them smaller. Okay, and then yeah, that's pretty much what we're doing today, but I'm gonna give you some questions where I'll make you start right from scratch. So you have to do the empirical formula first, like actually find it, then do the step where you find the multiple and then bump up the subscripts, okay? All right, everyone always needs a couple examples, so I'm just going to do another similar one to example 1, and then, but if you feel like you're comfortable with example 1, you can jump to example 3 in the notes here, okay? All right, so, but I'm going to just do another one that's similar just because sometimes seeing a couple similar ones are good, okay? All right, so let's go to example 2 here. Okay, so here's example 2. Go through and analyze all the things that are given to you and even collect some stuff that's not given to you but that you can find, okay? All right, so we need to find the molecular formula for the following empirical formula. Okay, and just correct that. Okay, and you know the molar mass of the actual formula, okay? So, all right, so we know what's given to us. The empirical formula is given to us. It is KSO4, okay? All right, we are given the molar mass of the molecular formula. Okay, so it doesn't clearly say it, but just know, find the molecular formula given that empirical formula is this and the molar mass is this of the molecular formula, okay? So 273.2 grams per mole. Okay, so we know the molecular formula. We don't know the molecular formula of the empirical formula here, but we can find it right now. Let's do that. So we have 1 potassium, we have 1 sulfur, and we have 4 oxygens. Okay, so let's write those out. So potassium is 39.10. Again, we're not rounding, carrying all the digits that we see on the periodic table that we have. 1 sulfur, so 3207. And then we have 4 oxygens. Okay, and then add them up. Okay, so there's our molar mass now of our empirical formula, okay? And then we have our molar mass of our um, substance, like our actual substance, the molecular formula would represent, okay? All right, so, but what do we need to find? It says determine the molecular formula. Okay, so I'm just going to say MF for that. And again, you are trying to find this, okay? So you're trying to figure out um, this new formula for the actual substance. Because right now we have the simplest formula for it, the empirical formula. It might be that it's still the empirical formula here, but you got to still check it and make sure that you don't bump up the subscripts and so forth. Okay. All right. So next up, we're going to find our multiple here. So our multiple is found by taking the molar mass of the molecular formula and dividing it by the empirical formula. And I'm just checking here. Don't think this is on the formula sheet, so just, yeah, get it memorized. And yeah, so from here, okay, so let's fill it in. So we have 270. So we're just trying to figure out, okay, the actual substance has a molar mass of this, okay? So if the empirical formula, which is kind of like the skeleton formula of the substance, has a molar mass of that, how many times greater is that? So we're just dividing them. Okay, and then I get 1.99998, okay, so we can round that to 2. All right, so that's the factor we're going to multiply up by. So I guess that was the A step and the S step here. Okay, so we have our KSO4, our empirical formula. I'm just writing the subscripts here to remind you that there is a 1 there. All right, and then our multiple is 2, so you're going to multiply these all by 2. Okay, and then when you do that, you get your molecular formula. Okay. So you get K2S2O8. Okay, and then to get that last final mark, don't forget to write the therefore statement. Use your keywords. So don't say the answer is this, okay? Write the molecular formula. Those are the keywords. This way you're communicating with me, to me, using correct terminology, what it is that you are studying, what it is that you just found, okay? All right, so the molecular formula is K2S2O4, or O8, okay? Yeah, so there we go. Okay, so those are the nice simple ones where I already gave you the empirical formula here. So we just kind of went from here. Okay, so I'm gonna give you ones now that look similar to the questions that you did the other day with empirical formula. So you have to start from scratch. You have to find get it to mass, get it to moles, then get it to the mole ratio, then get it to empirical formula, then get it to molecular formula, etc. Okay, so just some extra steps, but if you are feeling comfortable here, then you're ready to move on to these next ones here. Okay, so read through the question here and let's collect everything that we know. Okay, so you're looking at, again, finding the molecular formula for vitamin C. And we know some information here. So we know the percent carbon is 40.5%. We know the percent hydrogen is 4.6%. And we know the percent oxygen is 54.5%. All right. Its molar mass is 176.14, okay? All right, so let's write that down as well. So we have the molecular formula, molar mass is that. Okay, all right, and that's it. We don't have the empirical formula this time, so we have to find it first before we kind of carry on like we did with example 1 and 2. So these are the things that we need to find. Well, in the end, we need to find the molecular formula, but step one, you need to find the empirical formula first. Okay, so again, you are looking at something that has carbon, hydrogen, okay, and oxygen in it. So you need to go through and find these things here. And then once you get to there, then you can go through the molecular formula steps here, okay? All right, so here's our plan. Okay, so just one more thing to add here. So you're trying to get to, I don't know, we'll use different letters here, I guess. You're trying to, oops, I'll use that as C. You're trying to find a multiple, okay, so that you can get eventually to the molecular formula here, okay? All right, so our first plan to find the empirical formula, so remember we are going to get the percentages to mass, then we're going to go to amount in moles, okay, and then we're going to go to mole ratio, and then we can get to the empirical formula, okay? And then our plan, our part two here, once we get the empirical formula, we're going to find our multiple, okay? Remember, that's molecular formula, molar mass divided by the empirical formula molar mass, okay? And then we'll do this last step here. All right, so that's the plan. So let's put it into motion here. So we'll start with the finding the empirical formula, okay? All right, so we're going to change up here. We're going to change all of these to masses. So mass of carbon. So again, we're assume 100 gram sample of vitamin C. And I know you can go to the internet and look up the formula for vitamin C, but let's just pretend we don't know it's vitamin C and we have to figure out the formula, okay? All right, so we have 40.5 grams, 4.6 grams for hydrogen, and oxygen, we have 54.5 grams, okay? All right, so we got everything to mass. Now we have to get to ourselves to moles, okay, to the mole island here. All right, so we're gonna go, so we're just gonna write mass here. And we have three elements here, carbon, hydrogen, and oxygen. So I'll build a little table here. All right, so the mass for those guys were 40.5 grams, 4.6 grams, and 54.5 grams here. Okay, and then we're gonna divide by the molar mass in order to get to the moles island, or the amount island, okay? Okay, so again, just keep in mind, a lot of teachers will call amount moles, so I just want you to, yeah, be able to use it both ways, okay? All right, so you're going to divide by the molar mass of carbon. Looking on your periodic table, that's 12.01, and hydrogen is 1.01, and oxygen is 16. Right, so let's divide those out. And we get 3.3721889-ish, okay? And then the next one's 4.6 divided by 1.01. So just, the whole point is carry a few digits here. And so again, these are all moles. All right, so we have all of our amounts in moles now. So the next step here is that we need to go to mole ratio. Okay, so how we do that is we're looking at the one that has the fewest number of moles here. So we're looking at carbon, it's the smallest one here. So we're going to set carbon to 1, right? So to do that, we divide this by itself. Okay, so then it becomes 1, and then we're trying to compare, okay, well, if there's 1 carbon, how many hydrogens are there? So we're going to divide by carbon's amount here. for all of them, and we get to our mole ratio. Okay, so again, we wanted to set carbon to 1, so we divided it by itself. So there's 1 carbon. Now we're trying to compare the other elements to carbon. So that's why we're dividing by carbon's amount to all of them. And so we're finding that it's 1.3 to 1 carbon. So 1.3 hydrogens to 1 carbon. 1 oxygen to 1 carbon, okay? But right now we can't have 0.3 of a hydrogen, so we want to just bump these up so we can get to a whole number. So the first one I'm going to try is I'm going to multiply by 2. So again, if you just multiply one of these and it comes out to like a number that's not a whole number, then you just go to the next one. So I'm going to try multiplying this one here. 1.35. Okay, and then I'll get 2.701186. So again, not a nice whole number. So like these ones will just be 2, and like that would be 2, right? So let's try another one here. Let's multiply by 3. So again, I'm going to take that middle one again. Okay, so if I multiply that by 3, so that's looking better. All right, and that'll be 3, and that'll be 3. Okay, so right now we're looking at carbon to hydrogen to oxygen ratio of 3 to 4 to 3. Okay, all right, so that's going to be our empirical formula. So carbon 3, hydrogen 4, oxygen 3. Okay, so that's our empirical formula then. All right. Right, and that's where we stopped, and we made a therefore statement last day. Okay, so what we are doing though, we just finished our little, mass to moles to, right. So we were going from mass to moles, right, jumping from those islands, and then by dividing by molar mass. So we got to empirical formula. We still have to do the second part here, where we have to get to the molecular formula of vitamin C. Okay. So right now we do have the empirical formula, the molecular formula, molar mass. We need the empirical formula, molar mass. So we do have the actual empirical formula now. So let's just kind of do some work right here and find the molar mass of the empirical formula here. Okay, so we have 3 carbons, 4 hydrogens, and 3 oxygens here. So that's 3 times 12.01. Okay, so let's crunch those out. Okay, and then we get 88.07, okay, grams per mole. All right, so we have the empirical formula molar mass now, okay? So that's for the empirical formula. Okay, so now what we need to do is we need to find our multiple. So we're going to find our multiple. So, sorry, this is getting a little bit messy here. I'll do it over here. So we'll do the multiple now. So we're going to take our molar mass of our molecular formula and our molar mass of our empirical formula. Okay, so if I look back up here, it was 176.14. Okay, so that's for the molecular formula. We want to see how many times greater it is than the empirical formula, so we can get our multiple. And we find that it's 2. Okay, exactly 2, which is nice. Okay, so now that we have our multiple here, we have our empirical formula here, we can come back to our empirical formula and multiply by our multiple of 2. And when we do that, we get our molecular formula of C6H8O6, like that. Okay, so there's our molecular formula. So let's make a therefore statement. Okay, molecular formula is C6, H8, and O6, like that. Okay. All right. So yeah, so that's what you need to do. A lot more work, yes, but be able to do a question like that. But at least it kind of takes what you did last day, and then we're just going a few more steps more. But then you got both of these down. Okay. So again, take your percent composition data, change it to mass. Okay. Kind of make this table here. Change your mass to amount by divided by molar mass. Okay. Then we have to figure out, okay, if I have one of these, how many of those do I have? So I wanted to figure out carbon was one because it had the fewest number of moles. So then we divided it and we found that it wasn't looking nice here for hydrogen. So we were bumping it up until it looked nice. Okay, so times 3 worked. So we have a 3 to 4 to 3 ratio of carbon, hydrogen, oxygen for our empirical formula. Okay, but then we got to keep going. Find the empirical formula for molar mass for the empirical formula. There it is. Then divide it, get your multiple, multiply it up, and then finally get to your molecular formula. Okay, so really the new stuff is like, I guess, in these two boxes here. Okay, and multiplying it up and then writing our therefore statement. Okay, so I'm going to provide another example here. Just again, it always is helpful to see more than one. But if you're good to go, go ahead and try some of the practice questions and try the checkpoint. Okay. All right, so move to here. Oops, example 4. Okay, so we have a few different elements here again, and we just have the percent composition. So let's drop these down. Again, you don't have to do all of these steps, but it's a good idea. Just if you're gonna keep continuing to take, chemistry and physics and stuff like that, and maybe even business, just kind of write down, organize your thoughts on all this information that you have, and then what it is that you have to find. Okay, so here we have 64.3% carbon, 7.2% hydrogen. So, and then it says, okay, and then the rest is oxygen. So you are going to find that by just, everything has to add up to 100. Okay, so you're going to subtract 64.3 and 7.2 to find what's remaining. And out of the after combining those two and subtracting by 100, you will have 28.5% oxygen left. So to add up to 100, okay? Okay, so there's your oxygen, and again, we're just going to convert to mass. Let's see here, let's squeeze that in here. So mass of carbon. So again, we made the assumption we have a 100-gram sample. So then if we have a 100-gram sample, we'll have these masses. And again, always carry as many digits as possible here, okay? All right, so then from there, we have one more piece of information. We know the molar mass of the final formula that we need to use is right here. Okay, so again, without this, like we didn't have this last day, without it, we can't find the molecular formula. This is key, okay? All right, so that's given to us. And now we are looking at what is it that we have to find. We have to find, well, step 1, we're going to find the empirical formula first. Step 2, then we'll find the molecular formula. Okay, so we have to kind of find both of those. All right, and our plan here, so for empirical formula, we're going to go mass, moles to the mole ratio. Okay, we're making that table, and that'll get us to the empirical formula. And then with the molecular formula, you're going to start, you're going to find that multiple first, right? So we're going to call it the multiple. You're going to take the molar mass of the molecular formula and divide by the molar mass of the empirical formula. Okay, and then multiply up the subscripts, and then you got your molecular formula. All right, so let's go through and do that. All right, so make our table of carbon, hydrogen, oxygen. Okay, so we have our mass. So I'm just gonna go through and just kind of write out the table here. Stop the video. So I went ahead here and we found the molar mass by looking at the periodic tables. Those are the masses on the periodic table. We're dividing them and then we get to our amount in moles. And then we need to compare the moles and write the mole ratio here. Okay, so go to the mole ratio. So again, we want to compare to the smallest amount here. So we're analyzing an oxygen here as the smallest amount. So we're going to divide oxygen by itself and then get it to 1. And then we're going to figure out, okay, there's 1 oxygen, how many carbon and hydrogens are there? Okay, so so we divided all the amounts by the oxygen because oxygen had the fewest number of moles. So we divide them, so now we have 1 oxygen and we're trying to compare the carbon and hydrogens. And so these are looking like nice close to whole numbers here, so we're just making a ratio of carbon to hydrogen to oxygen will be a 3 to 4 to 1 ratio, okay? So then we can present our empirical formula here. Okay, I'm not going to write the 1 there. Right, so there's our empirical formula. Okay, so we didn't have to multiply these up because they were close to whole numbers here, okay? All right, so that's the empirical formula. So now what we'll do here is we need to find the molecular mass of the empirical formula. All right, so we'll go 3 times 12.01, 4 hydrogens, and 1 oxygen. Okay, and then we get to 56.07. Okay, all right, so we have our empirical formula, molecular mass. We have our molecular formula molar mass. So now we're going to find our multiple over here. Okay, so how many times greater is the molecular formula molar mass to the empirical formula molar mass? Then we can get right to our molecular formula. Okay, so 168.21 divided by the empirical formula molar mass. Okay, and it comes out to a nice 3. Okay, so I know we saw one example up there that it came out to 1.9999, so that's close enough, that's 2. All right, so then from there, we know we're going to multiply all of these guys by 3 to get to our empirical formula. Okay, so let's actually put the 1 in to remind yourself you're multiplying by something there. So the molecular formula is now C9H12O3. Right, and then write your therefore statement. Use your keyword. Okay, so there you go. All right, so just I know there's a lot of work with the last 2 examples, but just again, practice a few more just so that you know the steps, you know what to do next, and then you're good to go. And then yes, try the checkpoint.